So hello students, welcome back to the today's session of Elements of Civil Engineering. So in the today's class we are going to solve the problems on trusses by method of joints. So as we have already discussed in the theory part, we are having the two methods to analyze the trusses. Analysis is nothing but you are going to find out what is the axial force which is developed in the member because of the external loads. So in that we are having the two method, one is method of joints and another one is method of section. So in the today's class we are going to discuss how we are going to analyze this truss by the method of joint. So means what? As the name indicates, we are considering the different joints to find out the axial, that is internal axial forces which is developed in the different member. So just you can concentrate on this. Analyze the given truss as shown in figure by the method of joints. So we have already discussed, so what are all the steps you need to follow in order to analyze the truss by the method of joint. The same steps you need to follow here. So first thing is what you need to do. So you need to find out whether the truss is statically determinant or indeterminate. That is the step 1. So what we need to do? So we need to find out whether the given truss is statically determinant or indeterminate. So as I told you, indeterminancy we are having the two types. One is the external indeterminancy and another one is internal indeterminancy. So external indeterminancy is nothing but you are going to consider whatever the support which is provided for the truss, and internal indeterminancy is nothing but you are going to consider the different members and joints which are present in the given truss. So we are having the formula, that is external indeterminancy is equal to capital letter R minus small letter r. R is nothing but the number of reaction and small letter r is nothing but the number of equilibrium equations which is available to solve the problem. So and internal indeterminancy we are having an equation, this we have already discussed how we are going to consider, that is m minus 2j minus 3 is the equation we are using to find out the internal indeterminancy. M is nothing but number of members and J is nothing but the number of joints here. So capital letter R, I have told you, this is the number of reaction. So you just observe whatever the truss which is given. At A it is supported with a roller support. So we know that for roller support we are having only one reaction. So let us consider that reaction as a RA, or it may be one reaction. So and at F we are having the hinged support, two reaction, one is horizontal, that is RF, and another one is vertical. You can consider RF X and Y for your reference. You just count here. We are having the three reactions, RA, RFY and RFX. So therefore I can write the number of reactions which is present in the given truss as 3. Clear? So now the equilibrium conditions are available. So how many equilibrium? Summation of horizontal force is equal to 0, summation of vertical force is equal to 0, summation of moment at any point is equal to 0. So these are all the three equilibrium conditions are available. So that I can write the equilibrium condition available are 3. So now it is over, plus now we need to find out the internal indeterminancy. M is nothing but the number of members, J is nothing but the number of joints. What you need to do? You need to count the number of members which is present in the given truss. Just I will write. So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in the given truss we are having the 9 members here, just I will write it as a 9, and number of joints, you just observe joint A, B, C, D is there, E is there and F is there. So totally how many joints are there? 6 joints are there. 2 into 6 minus 3. So by solving this we are getting the indeterminacy as a 0. So means we can conclude, so the given truss is statically determinate truss. So that what you can write, hence the truss, whatever the given truss is there, statically determinate. So this is first step, it is over. So we have calculated, so we have find out so whether the truss is statically determinate or indeterminate truss. Is it clear? Are you following? Yes?
Yes, ma'am.
Okay. So next is the second step, just I will write. What is the second step? So we are going to find out the support reaction, just I will write it as step 2. So that is, what is the step 2? Calculation of support reactions. So you just observe here, only we are having the 2 supports. One support is provided at point A and another support is provided at point F, support reaction. And you just observe what are all the different forces which is acting on the truss, that is at the joints. You just observe on the member we are not having any force. At the joint C we are having 1000 Newton, at the joint E we are having the 1000 Newton. So now we need to apply the equilibrium condition and find out the what is the support reaction, that is RA, RF you need to find out. And you just observe in the given figure there is no any horizontal forces are acting, only the vertical forces are there, so that there is no necessity of considering horizontal. If it is horizontal force, if you are considering also, then it is 0 because there is no any horizontal forces here. So I will consider this as RA and this as RF. RF y is exist, RF x is 0 here. Just I will write for your reference that is RF x. So there is no any horizontal forces. So therefore I will apply summation of horizontal force is equal to 0. So there is no any horizontal force, therefore RF x is equal to 0. So now I am going to apply the second equilibrium condition, summation of vertical force is equal to 0. So how many vertical forces are there? Just observe the figure and let me answer. How many vertical forces are there including the reactions? See, RA is a vertical force moving upward, right? That is roller support is there, positive. Then RF is a vertical force moving upward, again it is positive. And 1000 at point C we are having 1000 and point E we are having 1000. Both are coming downward, therefore these are negative, that is minus 1000 is equal to 0. So thereby we are getting an equation RA plus RF is equal to 2000. So let us consider this as an equation 1. So summation of horizontal force is over, summation of vertical force is over. So now I need to apply the third equilibrium condition, summation of moment. So you can take at any one of the joint. I am taking the moment at the point A. Just I will take the moment at A is equal to 0. So moment due to RA about A will become 0 because it is acting at this point only. Just tell me what is the moment of this 1000 Newton about point A. What is the moment of 1000 Newton which is acting at point C about A? What is the moment due to this force about A?
1000 into 3.
1000 into 3, correct. So that is 1000. The perpendicular distance about that force to the point A is what? 3 here. And the direction you just observe. So in order to reach the point A, this force should come like this clockwise, therefore it is positive. Similarly, we are having the another 1000 Newton which is acting at point E. What is the moment due to this 1000 Newton which is acting at point E to the point A? 1000
into 6.
1000 into 6. Force is 1000, perpendicular distance is 6. And you just observe here the moment, that is Rfx is already 0 because now we are not having any horizontal force. So we need to consider moment due to Rf about point A. So what is the moment due to Rf about point A?
Minus Rf into 9.
Minus Rf into 9 because it is anti-clockwise direction, because force is here, point is here. In order to reach this, it should come like this, that is in the anti-clockwise direction, that is minus Rf into the perpendicular distance is 9 here, this is equal to 0. You just observe here in the entire equation only the unknown is Rf. By simplifying this, you will get a value of Rf as a 1000 Newton. By simplifying, you will get, just substitute this Rf in the equation 1, we are getting the Ra value also, that is also the 1000 Newton. So now the calculation of support reaction is over, that is Rf and Ra both are similar, that is 1000 Newton we are getting by the simplification. So this is what the second step. So now the actual method will start, that is the method of joints to find out the member forces TAB, TAC, what are the different members which are there in the truss, that you need to find out by the method of joint. So this is what the general procedure you need to do for all type of the problems. So then from the next step you are going to start with the actual procedure. So just observe here in the given figure, we are having the horizontal members also, we are having the inclined members also. So before going to start with this, you need to find out what is the inclination, because AB is inclined member, CD is inclined member, DF is inclined member. So first we need to find out what is the inclination of these inclined members with respect to horizontal or with respect to the vertical. So just observe here, this is what the distance is given, similar triangle is there, just observe 3 meter is given, and this is also 3 meter. So therefore we are getting the same inclination. So just I will write the inclination here, that is from the triangle, whatever the triangle you are considering, all are similar. So I can write it as theta is equal to tan inverse of horizontal is also 3, that is adjacent and hypotenuse, opposite and adjacent both are same, 3 by 3, that is equal to 45 degree. So means inclination of this inclined members about point A as well as point about horizontal axis and vertical axis are similar, that is we are getting the 45 degree. So if it is 45, then with respect to y also 45. So therefore whatever the inclined members are there, inclination with respect to x as well as y as a 45 degree we are getting. So this inclination we are going to use in case of the solving the, or in case of to determining the member forces. So this is over. The first step we have calculated whether it is statically determinant or indeterminate. Second step we have calculated the what is the support reactions which is provided for this truss. The next thing is we need to consider the each joint. Just concentrate here. I need to consider each joint and I need to apply the equilibrium condition. The calculation is simple. Only the thing is you need to apply the equilibrium condition. But how to choose the joint for the calculation, that is important. So because you need to consider all the joints here, but the joint should be chosen such a way that there should be minimum unknowns. So means maximum, if you are considering the joint A, means at joint A maximum you should have the 2 unknowns. If 3 unknowns are there, means we cannot find out it. So that the joint should be selected in such a way that unknowns are 2, that is maximum unknowns are 2. So that is as much as possible you need to choose the joint with a minimum unknowns. Maximum it should have the 3 unknowns. How it is, just I will show you. You just consider this joint A. So if you are considering joint A, just I will write what are all the members which is moving from the joint A. TAB is moving, right? TAC is moving, that is tension we are considering. At point, that is joint A, we are having one support reaction, that is RA is there. So this is what the free body diagram, if I considered at a joint A, you just observe RA is known, we have calculated, TAB is unknown, TAC is unknown, 2 unknowns. So therefore we can select the joint A. We cannot select the joint D first. So if we are considering the joint D first, means what happens? TBD unknown, TCD unknown, TDE unknown, all are unknowns here. 4 unknowns are there. We cannot solve it by using the equilibrium condition. So therefore I am going to consider the joint A first. How we need to draw the free body diagram, how we are going to apply the equilibrium condition, just we can see in detail here. Just the same problem is there, just I have copied the figure, you just observe. Just I am going to consider the point A, just I will write here, consider which joint? Consider joint A. I am going to consider the joint A first. Now I am drawing the free body diagram of joint A. So from joint A, if you are considering any point here, TAB is moving, just wait, okay. So this is point A, TAB is moving and TAC is there, right, and one support reaction is there. And here one important thing you need to consider, whatever the tension forces you are drawing, always the direction is away from the joint. So means you need to consider as the member is in tension. So if you are getting the negative value, then you are writing it is in the compression. But at the beginning, for your calculation, always you need to consider the member is moving away from the joint, that is in the tension. I am considering joint A. How I cannot write the direction here, but for your reference we need to follow any one. I am considering all the joints are moving away from the point, is nothing but tension member. And the support reaction you just write as it is, the vertically upward, you just consider as it is, and other forces you need to consider which is moving away from the joint. So this is joint A, I have considered, just I will write here TAB, just this is what TAB and this is TAC and this is what RA, we are having the RA value, that is 1000. And inclination we have already calculated, that is 45 degrees the inclination. Now I am going to apply the equilibrium condition here. Yes, is it clear? Have you understood how I am going to draw the free body diagram here? Is it clear? Just I am considering the joint A. I have written the forces which is acting on the joint A. Is it clear?
Yes, ma'am.
Okay. So now I need to apply the equilibrium condition. You just apply summation of vertical force is equal to 0 or else horizontal force, whatever you need to apply. So vertical force means we are having one inclined force is there. Just I am going to resolve this. Since the inclination is with respect to x axis, therefore x component is cos, TAB cos 45 is the x component and TAB sin 45 is the y component. So we are taking the summation of vertical force is 0, RA moving upward, therefore 1000 is positive, and TAB sin 45 is also moving upward, therefore TAB sin 45 is equal to what? 0. Clear? So now from this we are getting the value of TAB. You just take this 1000 that side, we are getting minus 1414.2 as a TAB by simplifying, that is Newton. So as I mentioned you, so if the value is negative, then you need to write the member is in compression. What is the meaning? I have considered the member is in tension here because the member is away from the joint, that is the direction I have considered like this. But by the calculation the value is negative. It indicates what? The direction of AB is in this direction, that is in the compression, not in the tension. So therefore after writing this value you need to mention which type of force it is, whether in the compression or it is in the tension. So that you need to mention here. So this is what our TAB value. Similarly, you need to apply the equilibrium condition. Summation of horizontal force is equal to 0. Horizontal force is nothing but TAC we are having. This is in the positive direction, and again TAB is also in the positive direction. TAB cos 45 is equal to 0. Clear? So now this is very important. You just observe TAB is negative value here. Clear? So therefore what you need to do, see TAC, just I will write as it is, TAC plus TAB is what? Minus 1414.2 into cos 45 is equal to 0. Clear? So then if you are considering this TAC, because it will go here, therefore TAC is positive, 1000 Newton you are getting. You just simplify it, you will get the value of 1000 Newton. If it is a positive value, what it indicates? It is in the tension. Our assumption is correct. Whatever the force TAC is there, that is in the tension. TAC. So TAB we have calculated, TAC we have calculated. You just, these forces are very important, along with the whatever the sign convention. If it is positive, negative, you need to consider this only. So in your textbook there are different ways are there, because they have already changed the direction based on the compression as well as tension, but you need to follow any one of the step. You need to consider all the forces are tension only. Whatever the sign you are getting while calculating, you need to consider that sign only, because if it is minus, you just consider minus only. If it is positive, you just consider positive only. For all the joints, while drawing the free body diagram, you need to show the forces which is moving away from the joint only. So now TAB is over, TAC is over. So now I need to consider the joint, another joint, such that the unknowns are 2. Joint A is over. Now I am going to consider the joint B. Consider, just I will write this one, consider which joint? That is joint B. I will write the free body diagram at joint B here. Just I will write the free body diagram, you just observe. Joint B is there. How many forces? If you are considering point B, one force, that is I will write it as, and another force is there here like this, and another force is there, this one. As I told you, you need to show the direction of forces moving away from the joint. I will write the what all the members are there, that is T, BD, this is TBC and this is TBA. Which joint? Joint B. So now just observe, by the previous calculation we are already having the value of TAB. TAB and BA are same. TAB value we are already having, that is minus 1414.2. Just I will write the value here, that is what is the value of this TAB, that is minus 1414.2 is our TAB value, already we are having. So now the unknowns are 2, so that we can consider joint B, because the joint should be considered such a way that there are only 2 unknowns in the joint. TAB is already known, TBC and TBD we need to calculate. And this inclination is known, either you can consider with respect to x axis or y axis, since it is 45 degree, therefore it is same. So just I have considered now, it is with respect to y axis. Is it clear? Are you following the things how we are going to consider the free body diagram? Yes, are you following? Yes or no? Just we need to consider the different joints. Okay. Okay, you need to draw the free body diagram. Just I am writing the tension forces, as we have solved the many problems in the previous module, similar way. But what here we need to do, we need to consider the particular joint. From that joint you need to draw the tension forces which is moving. And regarding direction, as I told you, always you write it as a moving away from the joint. But one thing you need to remember, whatever the sign convention you are writing, you write as it is. So you have shown the tension here, but you have written the minus, means it is understood that is in the compression. But for our calculation, in order to avoid the confusions, I am taking the direction of all the forces which is moving away from the joint. That's it. So now the joint is ready, free body diagram is ready. Only the thing is applying of the equilibrium condition. Just I will make it fast. Summation of horizontal force is equal to 0. TBD is horizontal force which is in the positive direction, therefore positive. And another, this you need to resolve. One is like this and another one is like this, resolution. So since TABA is making an angle 45 with respect to y axis, I have considered, therefore y component is cos, x component is sin. I am writing the x component here, therefore TAB or TBA, TAB, that is in the negative direction, that is sin 45 is equal to 0. So now carefully you need to substitute the value. TBD minus TAB value is already minus is there, negative, that is minus 1414.2 into sin 45 is equal to 0. Though this sign convention is very important, so if you miss this one, you will get the entire values are wrong, because compression, tension is very important here. So whether the member is in compression, tension, so that is very important. So here already it is in the negative direction, so therefore it is minus, but TAB is also negative. I have put in bracket here, minus 144.2. So by simplifying this, that is TBD, I am getting the value of plus 1000 is equal to 0. If you are taking that outside, that is TBD is equal to minus 1000. It indicates what our member is in compression. So that is, we have obtained the value of TBD, but that is in the compression. So TBD is over. Again I need to apply this second equilibrium condition. Summation of vertical force is equal to 0. So vertical force is nothing but TBC, which is moving downward, therefore minus again TBA or TAB, which is moving downward, and y component is cos here, cos 45 is equal to 0. So thereby you are getting the TBC is equal to, so TBC again TBC, that is minus TBC is there, minus of TAB value again minus 1414.2 14.2 cos 45, right. So therefore is equal to 0. TBC, sign conventions are very important, is equal to positive, we are getting the 1000 Newton. You just check it once using the calci, therefore I am writing it as a tension. So just compression and tension, the mentioning of this is very important. TBC is over. Joint A is over, joint B is over. So now I need to consider the remaining joint. So remaining joint means what? You just consider the joint such a way that there should be a minimum unknowns. So next, which joint I am going to consider here? So you just observe joint C, you just observe AC we have already known by the previous calculation, CB is also known, and this is 1000 given. These two are unknowns here. So means two unknowns are there. So therefore easily now I can choose the joint A for the calculation. Clear? So that is what the joint A. Just I am considering the joint A, I am writing the free body diagram here. So now which joint I am going to consider? I am going to consider the joint A here. Just wait. Okay. Just wait for a while. Okay. So now I am going to consider joint C. Just I am considering the joint C here. So joint C means I am going to draw the free body diagram here. Just observe it carefully. Just I will write T, this one TCA 1000 and TCD is there, and again T BC is there, another force TCE is there. So this is what the different forces which is acting on a joint D. That is what the free body diagram I have written. Just I will write the values first. This is 1000 we are having, and this is TAC. So TAC value by the previous calculation it is 1000, we have already calculated. Just write there as it is, and this is TBC, this is also 1000. You just observe the previous calculation we have already obtained. This is 45 degree, and now this is TCE and TCD. Only the thing, just I have written the free body diagram. So now it is coplanar concurrent force system. So this type of problem we have already solved. Just to apply the equilibrium conditions to find out the unknowns. In the entire equation, TBC is known, TAC is known, TCD and TCE is unknown. Just I need to apply the equilibrium condition and find out the unknown. So that is joint C. I have considered summation of horizontal forces equal to 0. I need to follow this sign convention, positive, positive, negative, negative. So this AC is in negative direction, that is minus 1000. I will write the direct value, TAC value is 1000, and plus TCE, just I will write as it is TCE plus, then minus TCD, that is this one. That is TCD, that is in the positive direction, that is TCD into cos 45 is equal to 0. Right? You just keep as it is because TCE is also unknown, TCD is also unknown. Just consider this as equation 1. Just I am going to apply summation of vertical force is equal to 0. Vertical force means 1000 is coming downward, right, minus, and this 1000, that is TBC, is moving upward, therefore positive 1000, and again the vertical component of this inclined force, that is moving upward, therefore TCD, that is sin 45 is equal to 0. Clear? By simplifying this, you just operate your calc and simplify. CD value we are getting it as a 0, means the member force TCD is 0. Just substitute this CD value in this equation. We are getting the value of TCE. By substituting that, we are getting the value of TCE is equal to 1000, that is in the tension. So if 0 means no need of writing this because it is 0, neither compression nor it is tension. So now the joint C is over. So next I need to consider the another joint such that we need to find out the unknown. So here the procedure is same, but after the knowing of unknowns, we need to consider the different joints for the calculation. Just now I am going to consider the joint D. Yes, are you following? Are you following? See, these kind of problems you have already solved, that is coplanar concurrent force system. Just I am taking with the method of joints by using this analysis of trusses, that is it. So this is procedure is common for you, you have already solved. Just I am considering the joint D, just I will show in the figure only. T DB is there, TDC, TDE and TDF. The same thing I am writing here, and no need of writing this because TCD value is 0 by the calculation. So therefore this member, there is no necessity of writing this member. The same thing I will write in the free body diagram, that is TBD, clear, and from this TDE, the same thing I am writing, whatever I have highlighted. So this is TDE, just I will write the values, and CD is 0, therefore I have not written. So if you are confused means you can show it as this also, that is this force TCD, but it is 0, no need of considering this. Just I will write this is TDE and this is TDF, you just observe the notations, and this is TBD. So TBD value we have already calculated in the first calculation, that is by considering the joint A. You just observe here TBD, you just observe, this is what the TBD value, minus 1000 is there, that is compression. Just write this value in the calculation, you are getting the value. Just TBD I am writing here because already we are having the value of TBD, that is minus 1000. This is point D, this is 45 degree because I have already calculated what is the inclination. So now I am going to apply the equilibrium condition. So what is the equilibrium condition? Summation of horizontal force 0, summation of vertical force 0. Just I am applying the, that is summation of horizontal force is equal to 0. For this joint I am applying minus, this is in the negative direction, therefore I have written it as a minus TBD. TBD value is again minus 1000, that is minus 1000. Clear? Again this is no need of considering, and again inclined force is there, one horizontal component, one vertical component. Horizontal component is in the positive direction, plus TDF sin 45, because inclination with respect to y component is cos, I am writing the x component, therefore it is sin 45 is equal to 0. So by this, by simplifying, we are getting the value of TDF is equal to minus 1414.2. If it is minus, I need to write it as the compression, right? So now TDF I have calculated. So what is this TDF? Similarly, I need to apply summation of vertical force is equal to 0. So that is vertical force means TDE coming downward, therefore it is so therefore it is a negative TDE, and again minus, this is also coming downward, minus TDF cos 45, this is equal to 0. So now carefully you need to substitute TDE as it is minus TDF value. TDF value is again minus here, minus 1414.2 into cos 45 is equal to what? 0. So by this you are getting the, by simplification, TDE is equal to what? Plus 1000. You just check it afterwards, that is tension. So only the thing is you need to find out the member forces. This is what? TDE, and this is TDF. Joint D is also over. Now you need to see the figure. So you just observe, by considering joint A, I have calculated AB, AC is known, BC is known, CD is over, BD is over, DE is over, and DF is also over. So now the remaining members, what are all the remaining members? The remaining member, the only one member is there, that is TEF. This is also we have calculated, only unknown is TEF here. So this member you need to find out here. So in order to find out that member, either I can consider the joint F or else I can consider the joint E. So just observe here, just I will write the joint E free body diagram. So if you are considering joint E, one force is acting 1000 downward, another force TCE, and another TDE, and another TEF. So this is what the free body diagram of joint E. Just I am writing here, so just concentrate, I am writing the free body diagram of joint E. Which joint I am considering? That is joint E I am going to consider. Just now I have shown, just I am going to write the free body diagram. E is there, from E point we are having TEF, and from E point we are having the TBD, and TEC is there. Just I am writing the free body diagram. Okay, this is 1 and this is 1 force, and again from this we are having one force, just I have shown in the figure, the same thing I am writing, and another force which is 1000 moving downward. Just I will write the values. Now you can clear with this. 1000 is a force acting at a point E, and TEF is another the tension member, and TED is there, and this is TEC. So TEC. So by the previous calculations we are having the value of TEC. TEC is 1000, just I will show, and TED is also 1000. If it is negative, you need to consider negative value only, but if it is positive, positive, and 1000. Only the unknown is TE. I will show you TEC as well as TED. See here, TED is 1000, TCE is also 1000 here. Just I will show you. Just observe. This is also 1000. This is also 1000. And I am writing the free body diagram at point E. You just observe. This is what the point E. The same free body diagram I have written. Only the unknown is TEF. That unknown I need to find out here by applying the equilibrium condition. Just I am applying the equilibrium condition. You just observe what we want TEF only. All the things are known. So, therefore, no need of applying the summation of vertical force is equal to 0. Just I am applying the summation of horizontal force is equal to 0. TEF is in the positive direction, therefore, it is positive, and minus TCE is in the negative direction, therefore, minus 1000 is equal to 0. So, by this I am getting the value of TEF as 1000 is the value of TEF. Since it is positive, therefore, it is in the tension. So, now all the member forces are over here, clear? So, all the member forces are over. Then now the thing is, you need to draw the truss which is showing the different forces which is acting. So, just concentrate. Just I am to show you how I need to draw the given truss. You just draw the truss as it is. Just I am writing. This is what the given truss, right? Okay. So, this is what the given truss. So, now above the member I am writing the values. You just observe the values. Above the member I need to write the values here. Just I will name it as A, this is A, and B, C, D, E and F. So, now we are already having the values. You just go through the previous value. Just I will write here directly because I have already calculated, that is AB is 114.2 and BD is minus 1000, right, and this BC is 1000 positive and this CD is 0 and again DE is 1000 we have calculated, and this AC is also 1000 and CE is also 1000 and EF, you can observe here, EF is also 1000. Just I am writing the same thing, and DF is minus 1414.2 Newton. So, these are all the member forces. Minus indicates that is in the compression and plus indicates the member is in the tension. So, this is what the figure or a truss which is showing the different axial forces which is acting on a member. Yes, is it clear? So, now you need to make this as in the form of tabular column. How we need to show this? So, you need to show all the members in the form of tabular column. You just observe here the tabular column is there. So, you just observe. So, this is what the tabular column. So, like this member AB, BC, CD, magnitude you need to write, and the whether it is in the compression or tension you need to mention. So, as we have already seen, this CD is 0, written as it is, CD is 0, no need of tension. AB, BC, you make the list of this and the nature of forces, whether it is compression or tension, so that you need to show. So, along with this you need to draw the tabular column such that the first tabular column is showing the serial number, and again member, which member you are writing, and for the magnitude how much it is, magnitude of force and the nature of the force. Just I will write for an example 1, that is 1 member is nothing but AB member, magnitude how much it is, minus 1414.2, and the nature, since it is a negative, that is in the compression. Similarly, second member, that is AC, you just consider, since the magnitude is 1000, nature if it is positive, therefore it is tension and compression. So, like that you need to make the list of all the axial forces which is acting on a member. So this is what the complete procedure how we need to analyze the truss using the method of joints. Is it clear? It is lengthy procedure, but only the thing is applying of the equilibrium condition. So don't get confused, don't get hesitate, because the procedure is lengthy but method is very simple. The truss is given, only you need to find out whether it is statically determinant or indeterminate. So then you need to find out the support reaction by applying the same equilibrium condition. Again you need to consider the different joints. What you need to remember while considering the joint should have the minimum unknown. A minimum common sense it is, because we cannot consider the point D first, all are unknown. So that first joint should be chosen such that there is a maximum 2 unknowns. You just observe it carefully and choose it. The next thing is only the applying of the equilibrium condition. You just observe joint A I have considered, applied the equilibrium condition, joint B applied, and the different axial forces I have calculated. If it is compression, mention it as compression, negative value compression, positive value tension. Similarly, I have considered the next joint, that is joint C, joint D and the joint E. So such that you should find out all the member forces which is present in the given truss. So this is what the complete procedure for the analysis of truss using the method of joints. Is it clear? Is it clear? So very easy steps are there, but it is somewhat lengthy. Let it be. We are going to solve some more problems in the upcoming sessions. So yes, it is lengthy procedure, but the applying of the equilibrium condition, considering the sign convention, is very important. That is, this is what the session which is give you the complete procedure of analysis of truss using the method of joint. So let us continue some more problems in the next session.